Your first assignment asks you to choose between a chemical or a physical change as you looked at it. Since we will deal the whole year with studying chemical changes, we want to make sure that you understand how to recognize a chemical change. There are 4 evidences of chemical change. Now, to put this in the terms that we were using in the previous part of this assignment, we talked about observations. The evidences are the observations. What can you perceive with your senses to determine if a chemical change has happened? Our inference is that the material has been changed chemically in some way. So this goes hand in hand with what we were talking about with your observations of the demonstrations. Based on what you saw in those demonstrations, I think you can safely establish in that first one that you saw since this involves it, let's use a color change. This is a little misleading. You can paint your fingernails. They're a different color. That wasn't a chemical change. This is the weakest of all the evidences that we can observe is when we see a change in color. Our second, looking at your second demonstration, you saw the formation of a gas. The material, the white powder, when the clear liquid was added, just bubbled over everywhere. Where did those bubbles come from? This is what we see, as bubbles. I hope you're taking notes. I know, hey, she's written them on the screen. Why can't I just print that? Well, sure you can. But the idea is that by writing them down, you're making a better pathway with the neurons in your brain so that you can recall it when you have to. Rather than just reading it, it's sometimes better to make those pathways, and that's really how we learn things. To make new pathways to get the information embedded and being able to recall it when we need it. Another evidence of chemical change we saw in the bonus demonstration, if you watched that, with the strip of magnesium metal. And you also saw it with white powder with clear liquid where we had a huge amount of steam coming off, and that created a change in energy. And that change in energy could be seen as heat, as you saw. And yes, I could not pick up the beaker with the black material in it for several minutes because it was way too hot. A lot of energy was released. And when you saw the burning strip of magnesium, you saw the energy in the form of light. Our fourth evidence of chemical change is a little more tricky. When the clear liquid had drops of another clear liquid added to it, a yellow precipitant appeared. I hope you could discern in that video that the yellow material that suddenly appeared there was a solid and started to settle to the bottom. It was not a yellow liquid, it was a yellow solid that would separate out. So let's get some definitions and some little more detail about each of this. Overall, when we talk about chemical change, we often use a triangle for delta, Greek letter for D, to express that change. That's just shorthand way of expressing it. Of these 4 evidences of chemical change, when we look at color change to tell if it's chemical instead of physical, we often talk about a chemical indicator, and that's a material that changes color in response to certain chemicals. The material you saw in the demonstration was actually milk of magnesia. It's something you take for upset stomach. And added to that was a chemical indicator called universal indicator. In that, there is a material called litmus. You may have played with litmus paper in other classes. What did it do? It told you if the material was an acid or base. The milk magnesia is a base, and it had its certain color, the dark blue or purplish color. And as we added an acid the color changed. And as the two reacted with each other, acid and base, we saw the color change yet again. It went from blue to red and back to an in-between yellowish or even green if we had kept adding it. So rather than assuming that it was a physical change, we knew we painted the wall. You can change the color of a piece of paper by putting your drawing on it. Those will all be physical changes. But when it's a chemical change involved with the change in color, we usually have a chemical indicator there to express that. Let's look at the second, formation of a gas. The bubbles appeared not because we put it in the microwave and heated it up. We didn't apply any kind of energy to this situation. We just poured a liquid on top of some powder and suddenly the bubbles appeared. So we are talking about something that's not a change in state, or I will say phase, a phase of matter. That would be a physical change. But a chemical formation of a gas is when a new substance is produced by two different materials. For change in energy, energy can be found in the form of heat, light, and even sound. This change in energy is the release of energy that used to be held within the chemical bonds. Where did this energy come from? Well, we didn't put it on the stove. We didn't put it in the microwave. We didn't hold it in a Bunsen burner. Where did the energy come from? That energy was released from chemical bonds breaking and reforming as the chemical reaction happened. It did not take as much energy as was once stored in the original materials to make the new material, and the extra energy was released to the environment. We saw that as the bright light from the burning magnesium strip, and we saw it as heat in the reaction of, all right, that was powdered sugar, and yes, that was sulfuric acid or battery acid poured on top of it, and that was known as the dehydration of sugar. All that smoke you saw coming out, most of it was steam, just simply water turned into a vapor. In the formation of a precipitant is a new word. Well, maybe not a completely new word. This is a solid that forms and falls, thanks to gravity, from a solution. You're familiar with the precipitation being rain. That's a liquid that falls from a gas state. And why does rain fall? Same reason, gravity. And as gravity acts on an enlarging particle, it falls. And so we say that it falls from the solution. We had it all mixed up, but suddenly a new material was formed when we added the two chemicals, and that material doesn't dissolve in the water. It won't stay in the solution. It all lumps together, it becomes heavy, and gravity pulls it down. This is involving, as I say, an insoluble material that's formed in the chemical reaction. All of these observations that we made, the 4 demonstrations that you watched, all demonstrated there are 4 evidences of chemical change. We had some overlap. In one of the change in energy, we definitely saw color change. In the formation of a precipitant, we definitely saw color change. There was no color change in the formation of a gas, but in the change in energy demonstration with the dehydration of sugar, that one definitely also involved the formation of a gas. These, when you put them together, give you the idea that the change you've witnessed would be chemical rather than physical. A couple of them are a little tricky. You have to reason through about where did the gas come from, what caused the color change. But with these, we can infer based on what our senses perceive. We'll conclude with one final idea about observations. Most all of the observations that you are making in those demonstrations are known as qualitative observations. We could also make quantitative observations. Look at the roots of both of these. This one has quality and this one has quantity as their root. So we have the measurements, which we did not make. I could have told you that I poured a certain number of grams of white powder or a certain volume in milliliters of the liquid. This one deals with the measured amounts of material that are produced. An example would be, let's say, 26 milliliters. For the qualitative, these are the general qualities that you associate: color, texture, phase. As you write, study, and express these observations that you make in your lab situations that you'll be doing this year, you want to know the difference between a qualitative and a quantitative and be able to designate the observations you're making as one or the other. That's something that we'll be working on in your next assignment. I hope that these notes will help you. I hope that you'll be able to take them yourself and use them, but you can always fall back and look at this video and see mine.